I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life. Bonus edition.
Bonus edition. This was a really fun one. I love the bonus editions because I just like to go on Instagram and tell people to ask us anything they want. So we've got a lot of good ones. We also got a lot of emails with people writing in extra information. So that's always fun, like stuff that I don't necessarily have to research.
Nice.
So do you want to get into those, Jam?
Yes, I'd love to. This first one's a long one, but it's very cool and funny.
Yes, I'm excited about this first one.
So this is from Drew M., who is a chemistry teacher. Here's what Drew said. This is in regard to us talking about units of pressure and stuff. Which one was that, actually?
I think it was the Pop Rocks episode, but we also, I think, talked about it on the tires going flat episode.
Exactly. Okay, yeah.
So we've done it a few times.
So I think we talked about in that episode, like, I don't know what's the unit of pressure? There's different ones.
And there's so many ones. Yeah.
So Drew helped us out a lot.
Thanks, Drew. I was so excited when we got this.
He says, "Hi, I just started listening to your podcasts and I'm really enjoying them. I had to laugh a little bit during the Pop Rocks episode when talking about pressure units. I'm a teacher and my AP Chem class just finished their unit on gases. I love to point out the absurdity of all the units of pressure that we use. Here's a few common ones. Pascal, SI unit, and of course kilopascal is used more commonly because just Pascal on its own is really small.
Millimeters of mercury.
Millimeters of mercury. From Torricelli's original mercury thermometer, literally measuring the height of mercury. Tor, named in honor of Torricelli, but didn't replace the unit.
Yeah, my understanding is Tor and millimeters of mercury are the same thing.
Interesting. For some reason, water vapor tables always seem to be in Tor. ATM, essentially created to make one of something the standard, used lots of chemistry and gases.
An ATM is an atmosphere. It's usually one atmosphere's pressure is theoretically how much pressure is exerted on us from the atmosphere at sea level.
Right. I think that's what we talked about in one of their episodes more recently.
Yes.
Bar, and I've heard this one, this is used in espresso and coffee stuff a lot. One bar was defined as 100,000 kilopascals. One place bar, or millibar, is used when reporting pressure at the eye of a hurricane.
Oh, that's interesting.
Yeah. Inches of mercury. This is the typical unit of weathermen reporting atmospheric pressure. A private pilot friend also said they use mercury inches in flight plans.
Oh, I didn't know that.
That's kind of crazy. PSI, there's more.
That's what we've heard.
Yes. Which is pressure equals, what is that?
Force over area.
Oh. This became the standard English unit of pounds per square inch.
That PSI is one I've heard a lot.
Yeah.
I feel like that's in my tire pressure and things like that.
Yeah. Cars and bikes and stuff.
Yes.
That's what I've used. And then inches of water, or inches of H2O, used in some industrial places like compressors and pipelines.
Yeah. I didn't even know about some of those. Isn't that wild?
That's crazy. And then he says, that's only the commonly used units.
I don't know how common inches of water is because I've never heard that, but I have never worked in industry.
Right. And then he said, side note, when you talked about PSI in tires, when you inflate a tire to 32 PSI, that's actually 32 PSI plus the atmospheric pressure, which is negative 14.7 PSI.
I think that's roughly 14.7.
Which is roughly 14.7 PSI. The 32 PSI is gauge pressure, which is really different between pressure, the difference between pressure inside the tire or a basketball or whatever, and the external pressure. Like an uninflated balloon has around 1 atmosphere of pressure inside because it's open to these surroundings. Otherwise, it would be a vacuum.
Yes. So that makes sense because I've wondered 32 PSI didn't seem like a lot to me, but 32 PSI plus atmospheric pressure, that makes sense. We talked about being confused by that.
Right.
And didn't revisit it. So our high school chemistry teacher friend schooled us on pressure.
Yeah.
We appreciate you, Drew. Those are things that I heard some students talking in the hallway today about how they said this is really suspicious because my dad works in industry as a chemist, but he hasn't ever been able to help me on any of my chemistry homework or my organic chemistry homework. And it made me laugh because I was like, no, that totally checks out. As a chemist, I think that makes so much sense because a lot of what we learn in basic chemistry is a broad understanding. And then we start to get the little details and build foundational blocks. And some of it, I don't think we need to know as often in everyday life. And then when you go into industry or go into grad school or whatever, you specialize in an area and you don't think about those other areas ever again. Like I can't tell you how many things I never thought of until I started doing these episodes. So for a high school chemistry teacher who's teaching this consistently, this is like fresh on his mind.
Right.
But for me who does organic chemistry, which involves almost no math ever, that this is not something I almost ever think about.
Yeah. And I think what's interesting too, so like obviously Drew schooled us on that, but he also helped us realize that it really is a lot more absurd than maybe we thought.
Yeah, it's even more absurd than we were joking about.
And all these different industries and countries, and there are different reasons people have different units of measurement for pressure. They really do need to get together and talk about this, you know?
Yeah.
And figure this out for the rest of us.
My brother-in-law hates that we use the non-metric system.
Oh, yeah.
Because of this like one famous error that NASA made in converting from our system to the metric system and how much money it cost taxpayers. And he's like, it's so stupid. This cost X amount of dollars. Why don't we just switch over? But also I think in a lot of ways we already are standardized by the metric system so much. Like a gallon is standardized in terms of liters and our ounces are standardized in terms of milliliters in a lot of ways. So you know. Yeah.
It's just so much easier. And we only use grams and milliliters in the coffee world. That's pretty common. And so it's a lot easier. So many things are easier. It's like, otherwise, if you're using like something in the, what do you call it? Customary units or?
I think, is it the imperial system?
Or imperial system. If you're using that and then you convert to like milliliters and grams, it's always a weird number.
Yeah.
It's like, oh, this is like, this bottle of drink is 20 ounces or 16 ounces. But in milliliters or in liters, it's like 0.784 or whatever.
I think you'll find that a lot of them are actually weird numbers of ounces and they're standardized amounts of milliliters.
Maybe it's a mix, but like this is like a 16 ounce.
And our cups. But I meant in like water bottles they sell and fill in industries. I've started to notice it's like a lot of 12-ounce water bottles are actually like 11.7.
Oh, there we go. Okay, that's cool. I'm cool with that. They will just sneakily, maybe all of these different brands will sneakily start doing that if they haven't already.
So, okay, it's not 11.7. I don't know where I got that number from, but a lot of water bottles I have been noticing are 16.9 ounces because that corresponds to 500 milliliters. Yeah. So we think we're in the imperial system, I think is what it's called. Yeah. Empirical? I don't know. We think we're in the customary units in the United States a lot, but actually secretly behind closed doors, it's being standardized by the metric system and we just don't know it yet.
That's cool. That's interesting. I remember as a kid, getting a bottle of a drink at a convenience store or something was almost always 20 ounces. So it must be that has changed.
Maybe. I don't know. Or maybe it just says like roughly 20 ounces and it's actually, you know, because I would think of this always as 16 ounces. But if you look on the label, it's 16.9. Yeah. You know? But then also there's 12-ounce cans of soda and those are usually 12 ounces. So, you know, some things are maybe standardized and others aren't. Yeah. But they usually also have it in milliliters on there too. So, yeah. All that to say, we wouldn't even be having this conversation if we could just agree upon one system.
Yep, 100%.
And then it wouldn't be confusing anymore because it would just be standardized.
I know. Yeah, it'd be so nice.
But that actually, let's put a pin in this because a later question that someone asked is going to come back to the metric system, I think.
Okay.
So.
Okay, nice. This next message is from our friend Kaiba. And this is in regard to the name of the 20 carbon chain that we talked about a couple weeks ago, eicosane, which we discussed on that episode about how gasoline makes cars go. Kaiba said, biochemists know this because it's pretty common. It's part of our membranes, but we mammals cannot synthesize. So we get it from plants, but it's super important and present in many pathways.
Okay, so I decided, well, I'll say when I learned that, I thought that was really interesting. I'm going to go look some of this stuff up. But I also asked some of my other friends who teach organic chemistry, and they also had never heard of this number. So it's not just me as an organic chemist focused person. And then I went into my biochem textbook to try to learn more information. And also, this was not listed anywhere in my biochem textbook.
Okay.
So I did have to dig a little bit deeper. So I ended up going to PubChem and found that eicosane is a solid alkane. So it's one of those more waxy, solidy ones like we talked about in that episode. It's used in cosmetics, lubricants, plasticizers, and can also be sold as feeds for cracking for gasoline, right? Okay. We talked about that. And then some other chemistry reactions. And they also may be a component of diesel exhaust particles as well. But also I was excited because it said they're commonly found in lemon balm. And there's a genus of plants with my name, Melissa, because Melissa means honeybee in Greek.
Okay.
And so those plants that have a lot of nectar, they often have the name Melissa in their genus because it attracts honeybees. So there's a plant with a common name, lemon balm, that has a lot of eicosane in it. So, and its fancy name, its genus and species is Melissa officinalis.
Interesting.
Yeah. So then I was like, oh, how cool. But it can be commonly found in products that we use all the time. So I haven't heard of it, but that doesn't mean it's not useful. And it has a ton of different isomers, like we also talked about in that episode.
Nice.
So I went and learned something new. As a listener, Nicole said, if you're not learning something new every day, then you're not doing life right. So thanks for that encouragement, Nicole. And I did it. I went and learned something new today.
And what's nice is that I pretty much am guaranteed to learn something new every time we record. So that's good too.
That's true. That's true. I usually do too.
Yeah, that's true.
This is a bonus learning something new.
Yeah, definitely. This next question is from Gabby. And Gabby asks, why are the clouds white, but the sky and ocean are blue?
Guess what, Gabby? We answered that question. It's so fun that we have such a large backlog people sometimes miss those.
Yes.
You know?
Yeah.
So
and not every podcast app has this, but the one that I use has where you can go into a podcast and then within the podcast you can search to see if there's an episode that has something in the title or in the show notes. And I bet not every app has that, but if it does, you could always see if we have an episode about it. But
definitely.
No big deal.
But we also do have an episode about it.
Yeah.
So one of them is called Why is the Sky Blue? And another one is What are clouds and why do they look white? So you can go check those out. But the short answer is basically different sized water molecules scatter light differently, but water and light scattering is responsible for both of them, which is kind of cool.
Yeah.
That the same substance can give such different colors.
Yeah, definitely.
And then the next one, I'll actually read this because I think it requires a little bit of chemistry interpretation, is an email that Dr. Diana Mason sent us. Dr. Mason originally started the chemistry education program at UNT. She's since retired, and I think she recently moved to Austin, so congratulations on that, Dr. Mason. But she listens to the podcast, and she gave a little bit of feedback, which I think is good information to have. So she said, I just listened to your podcast on ice. As usual, I'm behind, which I don't think that's too far behind. No, because there's a few other items about that one too. She said, when you had people sit in chairs, I thought you would have them join hands to form the hydrogen bonds between the water molecules. And that's a really good thing that I probably didn't emphasize enough, is the intermolecular forces that hold those atoms together are hydrogen bonds, like we've talked about before. That's what holds water together. But also because hydrogen bonds specifically form between the really positive hydrogen and the really negative oxygen, those parts need to line up, which is why they sort of have that hexagonal hole in the middle of them. So we talked about the Mickey Mouse ears as an analogy, but I don't think I did hit hard enough the hydrogen bonds in the analogy. So that's a good way to sort of round out that analogy.
Got it.
And then our scientist / artist, Bridget, also wrote in some analogies about the water episode that I really liked. So do you want to share what she wrote in?
Yeah, definitely. So she said the first one it would be with seeds and planting. Imagine that the liquid water is just a bunch of acorns in a jar. It's halfway filled. It can move around freely-ish. When it comes time to plant all those acorns, you have to space them out in order to ensure the best likelihood that they'll grow into mature trees. You have to optimize their configuration in the ground, so to speak.
Oh, I really like that one because optimize their configuration does sort of get at the idea that they have to line up just right and they have to get the optimal bonds to settle in nicely into their frozen state.
Yeah. And then the next one she had is, let's say you're a new homeowner and you want to install a cobblestone path. You could buy as many cobblestones as you wish and stack them as freely in your trunk. It doesn't matter what configuration you stack them in since they're not going to be installed quite yet. But when you begin to create your path, there have to be gaps in between each stone to fill with gravel or grout or whatever. There's going to be a bit of space in between each stone in order to make sure that they're in an optimized configuration for foot traffic.
I also think there's gaps between them because of the shape of the stone, which even gets into the shape of the molecule. Like sometimes they can be close together at their widest part.
Right.
But maybe at the top part of the stone or whatever, so they don't fit in quite right to be nestled right next to each other.
Yeah.
And so that's also gets into the shape of the molecule, means that they have specific way they need to be arranged. So I really liked both of those. And I think it's so fun when people send in analogies and take the science and make it deeper. And that also gives a chance for us to remind our listeners about what we learned about on previous episodes. So that kind of jogs our memories and brings that back to the forefront of our minds, so it's easier to think about it again later, right?
Yeah,
I
definitely.
love that. So thank you so much for sending that in, Bree. And actually, both Bree and Dr. Mason sent us representations of water. I think Bree is still working on hers a little, but I'm going to try to post those next Thursday. Bree also made a beautiful rendering of the octane that we talked about in our gasoline episode.
Oh, nice.
So I'm going to try to post all this beautiful science art on our Instagram. But if you would go check out Bree at McAllister Bree on Twitter, she posts amazing scientific artwork. She does some on her Instagram as well. We follow her on both of our accounts, so you can check out her work. But yes, I love it. She'll send messages of different renderings of reactions and different things like that. And she's so talented. I'm so amazed. She takes the picture I have in my mind and puts it into digital artwork, which I don't understand that at all, how she does. But she's so talented. And so I really, really love it. So highly recommend you go support her. She's a big supporter of the podcast, and she just does such good artwork that makes me so excited to see the images in my mind come to life on the screen. She also asked us a few fun non-chemistry questions that I really liked. So let's get into those real quick.
Okay, sweet.
So I'm going to ask the first one.
Okay.
So she first asked a question specifically for Jam.
Okay.
Who doesn't get on Instagram very often, so I don't think he's seen this yet.
I have not.
She said, Jam, do you have any coffee making tips?
Oh.
Bonus if it's Chemex or pour over related.
Nice. Okay. I definitely have tips. And I'm an avid pour over guy. I use a V60 most of the time, and sometimes I use a Kalita.
What is a V60 for all of our listeners?
It's a type of pour over brewing vessel kind of thing, which is looks like a funnel, and it goes on top of either your mug or on top of a carafe. And then she mentioned Chemex, which is very similar. It just is a different size, and it's actually looks like an hourglass. The carafe is actually attached to the bottom. But they're really similar. A lot of things you could do with one, you could do with the other, but there's some differences that kind of matter, but we won't have to go into that. My biggest tip would be that is kind of like 12 tips in one is to go on YouTube and type in the Ultimate V60 Brewing Guide by James Hoffman.
Yeah, I love James Hoffman.
Yeah, he is mine and many people's coffee hero. His is great. I steal a lot of his tips, but two that I'll recommend is use boiling water.
Okay.
There's a myth out there that pour over people have followed for a long time, including myself. I used to, that you need to use lower temperature water, like 195 degrees Fahrenheit or 200 degrees Fahrenheit, something like that, 205.
I have heard that.
And James Hoffman's testing and other people's has proven that it just doesn't seem like it makes a difference for light roasted coffee. In fact, it actually extracts not as well because it's lower temperature water. And so
that makes sense. So it might maybe be taking less of the good flavors out. I think we had worried that if it was too hot, it would take some of the bitter flavors as well. But does that seem to not be true? It just gets mainly the good flavor molecule, good flavor compounds.
I think time is probably the bigger problem there.
Oh, that makes sense. Yeah.
And so at the pour over, it's going right through as long as you don't have too fine of a grind. So feel free, go against the grain of things you may have heard.
Go against the grind.
Yeah, go against the grind to use boiling water, and I think you'll probably be happy with it. That's how I felt.
That's cool.
And then the other tip is that I used to stir with a spoon after I'd initially pour my water in and do the pre-infusion or bloom. Different people call it different things. But now what I do is I pick up the pour over and I swirl it around a bit, and it's a much better. It does a much better job of getting everything evenly mixed together and helping get the CO2 out and allow bubbles to form and all that kind of stuff. Those are 2 tips that are super nerdy if you're someone who's never even heard about pour overs or Chemex or anything like that. And if you're someone who doesn't know what I'm talking about, all I'll say is go get some good, freshly, lightly roasted coffee beans from a local roaster near you.
Yeah.
And that will up your coffee game by like 20 times.
Shout out Good Coffee.
Yes.
Which does that.
Yes.
Nobody asked me for a coffee tip, but I'm just going to throw one out there that is James Hoffman approved. Is I like lattes. I don't drink coffee every day. I found actually it seems to like upset my stomach more than it helps me be awake. So I've just been trying to get enough sleep and not have to drink coffee for caffeine.
Yeah.
But I do enjoy a good espresso drink, but I don't have the money or the time to learn how to become a good espresso puller.
Right.
So a little tip for fake milk drinks, as James Hoffman calls them, is you can get a mocha pot, it almost works like a little tiny percolator, but it can make a stronger brew coffee, and you can mix that with like a little milk frother or a steamer, and you can have a imitation latte, and it's really good and it's close. It's the best thing I've made at home, and it saved me a lot of money going to the coffee shop Saturday mornings.
Yeah. Totally. Yeah, those seem like such a good option for that. And I think most people don't even know about them.
No, I had no idea.
Or if they do, they may not have had very good results because they're easy to mess up, unfortunately. But
yeah.
But they're really good. So
he has a good method that seems to make it really simple, and I have not had any major mess ups. The first few times we didn't have like the best results, but we've been able to get it down pretty quickly and easily.
Nice.
And it's been fun. Just like something to do on Saturday morning, instead of going to a coffee shop, we just try to make our mocha pot work.
Yeah.
The next question was for me, and Jam, you can chime in on this too, since I usurped your question.
Okay.
She asked me what my favorite cooking or baking chemistry tip was. And we did a whole episode on the fact that the bowl I was using for my icing mattered. It was one of our fall minis that we did last year because of the specific heat and the heat capacity of different material and objects, how much it could hold on to mattered. And so the frosting wasn't cooling down fast enough because I was using a thick, heavy porcelain bowl.
Okay.
And my metal bowl was better. So that kind of blew my mind.
Yeah.
But I think probably like a much more basic tip goes all the way back to our metric system versus the American system, whatever it's supposed to be called, is really you should weigh your flour. Because if you scoop it up, the particles can pack in differently. So if you're scooping 1 cup, it's not consistently going to give you the same weight.
Yeah.
So if you just get if you just get a kitchen scale, which Jam already has one for coffee and we use one for coffee too, you can just weigh out however much flour you want, and it's going to be a lot more consistent and accurate.
Yeah.
So that's my tip for that.
I love that tip. It's one of my pet peeves that how often recipes I'll look up for cooking will ask me to use something volumetric
Mm-hmm.
for something that's not even a liquid in the first place.
Yeah.
And so it's like, if it's like, oh, do a cup of berries. I'm like, okay. If
a
you
cup
get
of smushed berries?
Yeah. Do a cup of small berries and a cup of big berries, you will actually be having very different amounts of berries there.
Yeah.
And it just kills me. And the mass of something is so much better of an option if it's not a liquid.
Yep.
But you can make a pretty good argument that like volumetric for a liquid is pretty fine.
Right. Yeah. And I think they do that for liquid. They might use ounces, milliliters. I don't know. But for the most part, like they'll use tablespoons and stuff for liquids.
Yeah.
But really, you should weigh out especially flour. I think sugar is actually a little bit more consistent. But I know flour is a very big culprit of being weighed differently. But even brown sugar, it's like tightly packed or loosely packed, you know? So it's just easier to just weigh it out. I just have a kitchen scale that's in a drawer and we weigh everything out.
Yeah.
So that's my chemistry baking tip.
I don't bake, but I do cook, and I can't think of any sneaky cool thing. But just on the heels of the whole, weighing stuff deal, is that I highly recommend doing that for a bunch of stuff, but especially for coffee. I weigh both the beans instead of using scoops or something like that. That's so hard to get it to be accurate. And then I also weigh the water as I pour in the pour over. I know all that seems so excessive, but what's so nice about doing that is that you can tweak things a little bit, and it makes a kind of big difference. So say you like really nailed your cup of coffee one day, you would want to be able to do it again tomorrow. And it's a bummer if you're using really like generalized, not accurate ways of measuring stuff, or just not measuring at all and just eyeballing it. You might not be able to repeat what you did really well. And so that's why I love getting really specific. And you're not really even worried about measuring a ton of things. It's just the grams of the coffee beans and then weighing the grams or / milliliters of water.
Because 1 gram of water is equal to 1 milliliter volumetrically.
So it works really well. And obviously like going over like 1 milliliter of water is probably not a huge deal.
Right.
But like you'd be surprised how bad we are at eyeballing like the difference between like 10 and 20 milliliters of water or something like that. Like we're just not good at it. And so I'd highly recommend that you do that if you're a coffee person.
It seems like a lot at first. I remember thinking it seemed like a lot when my roommate started doing that. But now it just doesn't seem like a big deal at all. It just seems like, oh yeah, it makes sense. Weigh out exactly the amount that you want. And even I scoop out, I pre-portion my protein smoothies and my protein powder and stuff. And I've noticed that sometimes, even though I use all the same scoops and I do it one right after another, sometimes my jar will be filled all the way to the top, like tightly packed in there. And sometimes my little jar will have like a little bit of room at the top. And I'm like, what does that mean? My scoops are so inconsistent. Yeah. So I'm not going to weigh that, but coffee, it would matter a lot more. Yeah. This has a little more give in the flavor.
Yeah. Yeah.
Well, that's it for today, but I do want to do a few shout outs before we wrap things up.
Okay.
One, I've gotten a lot more emails about the ADHD episode, which is amazing, but I just found out that the Huberman Lab has some episodes, one that recently came out about focus and how to optimally focus your brain, whether or not you have ADHD. And he's a neuroscientist. And so he uses science, peer-reviewed journal articles, things like that. And he also mentioned that he has an episode about ADHD. So I can't wait to go back and listen to that.
Nice.
And then, we love learning from experts in their field.
100%.
That's something that we uniformly love on this podcast.
Yes.
So I was excited to hear him talk about neuroscience. And I almost was a neuroscience major. And then we wouldn't even have chemistry for your life.
Yeah.
Wild.
Dang.
And then also, I know that a lot of educators are using our content in their classroom. So I want to shout out Mr. Hollis and his students. They go on podcast walks where they walk around and listen to the podcast and then come back and discuss what they learned. And then Melissa Van Alstine Paris and Michelle Solomon, they both use the end of the year or the podcast as an end of the year project in their classrooms, both college and high school setting.
Nice.
And also in the university setting, my friend Andrea Van Wyk is a fellow chem ed person, yay. And she tweeted about how she's been using the podcast in her classroom to help her students to study and gain a deeper understanding before their first exam. So all those really made me so happy. I love hearing that we're able to support people in the classroom and be a platform that teachers can use to give their students everyday life context-based examples.
Yeah.
Makes me really excited. So if you're a teacher and you want to learn about how to incorporate this in your classroom, please reach out. And I am also working on building a list out where the episodes are organized by topic. So that's up right now. It's on my Linktree, and I think maybe on the Chemistry for Your Life one, but I don't know for sure. But it's definitely on Linktree/Organic Melissa, and hopefully on the Linktree/Chem for Your Life soon. And we're also working on maybe putting together a more navigable website with some of that information on.
Yes.
So we've got a lot of exciting things coming soon, and we are really excited to know that we're supporting educators. And please, educators, let us know what would be helpful to you, because we want to help you, because we know how hard it can be to manage all of the curriculum in a classroom.
Yeah.
So thank you guys so much. And then also let's shout out our Ko-Fi people who are also actively supporting listeners and people in the classroom learn more about chemistry.
Yes, this show costs us money to make, but we don't want to ever charge for the show. So
right.
we'll keep the show free. So these people are people who either every month help support us and cover the cost of the show, or give us a one-time kind of donation to do that. So last month, these are the people who have done that. It's Hunter R., Jacob T., Avishai B., a mystery Ko-Fi supporter, you know who you are, Tim P., Suzanne, who said, "Go Science."
That was so cute. That was her comment on her donation.
Derek L., Stephen B., Chelsea B., Brian K., and Christina G.
Thank you all so much for making the show possible. We literally would not be able to keep it going without you. And you've made it more accessible by keeping it free and by making sure we have transcripts for anyone who needs it. So thank you so, so much. And also, you guys helped contribute to us going to a conference and sharing Chemistry for Your Life with so many educators there to bring it to their classrooms.
Yes, thank you guys so much. All the best. Some of y'all have been with us for a while now, and so we're really grateful for you guys. This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.